Uh, it's fine actually. I think it's quiet enough. The construction's almost done. Got a little hot last night. Okay, welcome to week two. With Python, so we'll be doing some new stuff. Although as we go, we'll always be reviewing the same stuff that we have been doing. So hopefully, we'll be able to practice what we did last time as we go. So to begin, we'll be talking about the next type of data in Python. We've talked about int and float, which is just any quantity in Python, be it like a whole amount like 2, -5, that's the int. And a float is just any decimal, so like 2.0, 2.0, 7.7, -2.9, that's all floats. Those interchangeable. Then we did talk about types. We also talked about strings, which is just any text. And in Python, a string is just going to be something in quotations. So this is a string data object type. This is a int. And this is a float decimal. And I will give these each a new name. We talked about all of those. Today we'll be talking about the next type of data that we can use, and that's what's called a Boolean type. And it's really easy and it's going to be really useful. And all it is it's a type of data that only has two options, those two options being true and false. And it's going to be a way of allowing us to ask questions and judge situations to see what's going on. And it's going to quite quickly allow us to do conditional logic. So we can evaluate something as true and false, ask a question, and then say if true, let's do that. If false, let's do something else. So it's a really useful thing in coding, and you can use it in all types of situations. In the example we'll see, we'll be doing it with just quantities. Is 3 less than 10? Blah blah blah. So you can use Boolean values with almost any type of data. Is this string exactly equal to this string? Blah blah blah. You can just say is something equal to something less than the exact same different. All these use Boolean type values. Let's hop into the Replit and we'll do some examples. So we have these types up above, and down below, I'm just going to name my data object. I'll call it bool1. So when we do a data object, we can just give it any name on the left, set up an equal sign, and then we can do the data value and type at the same time. So in the data box, I'm going to give it a true-false value. In Python, all Boolean values have to be one of these two things. They have to be true or they have to be false. And you'll notice that I capitalized true and false. If you don't capitalize them, Python will get confused and actually not know what that is. You can see it's trying to suggest that's the bug. It has no idea what this is. So you just need the capital to really tell Python this is a Boolean value. So it's always going to be but it's not going to be in quotations. If we put it in quotations like this, then instead of a actual Boolean value, now it's a string with it just means true, the text, but it's not actually a true-false value. Okay, that's how you make them. That's what they look like. Well, now we'll see how to get them. We can just make an object instead of true and false, but we can also ask a question and get to a true-false by setting it up in Python. So we can ask some questions, and we can just use some basic math symbols in this. We'll set up a couple. I'm just printing this one line. So I'm asking, it's basically a question that we don't have, punctuation, but it is a question. It's asking, is 3 greater than 10? In this case, that's false. So this equates to false. That's what prints out. We can see that the same thing happens if we do something like this. I can make a new data object, give the name bool3, that's just the name I gave it, And I can set it equal to this like conditional logic, conditional expression using these math symbols. And then this is going to evaluate to, in this case, false. So this is equal to false, and we can see that comes out on this side. So we can kind of do it two ways. We can just set it to true and false, and we can do kind of an expression and then evaluate it and then get it to come out that way. So we have that. We have stuff. I'll just show you all the symbols. And again, the spacing between some of these symbols, it's just convention. I can skip the spacing and it'll come out just as fine. Although, like I said, usually in Python, people tend to do like a single space between each, thing off by itself. So is 3 less than 10? In this case, that is true. We have this is we have the less than symbol. We have the greater than symbol, and then we also have this 3. We also have less than or equal to, and obviously the opposite. Like that. That's going to be all the symbols we can use to like ask questions to see if something is true or false. And then in a second, we'll be able to ask on different branches of logic to do this if it's true and this if it's false. This is just the stuff that we can do with math. You can do stuff with like strings. We can ask, one thing. Let me set this up and I'll explain it. So in this one, I'm not evaluating a conditional expression of like math. It's just evaluating X strings, conditional expression. I'm just asking, is something equal to something? I can't ask if like John is less than Jake, because it's not really, you can't really do math with language. But this symbol, the double equal sign, that means is equal to. So I think we just say is equal to, it's just going to be the equal sign, but since we already use the equal sign in Python, the assignment symbol, aka put this value inside this data box, we can't use it again to mean something else. That's why when we want to ask if something is equal to something, that's what this question is saying, is John equal to the text John, aka is it the exact same? We use the double equal sign in this case. And you can see when I print out condition, the last one is false. And that's because Python is case sensitive. So if I change it to be John equals John and run that, now you can see it equals true. So we can use conditional logic with strings and different things as well. But we'll mostly just be focusing on like using it with math, because that's the most obvious and most useful example. Okay. Now that we have the ability to ask questions and like know what we want to do, true and false, we'll be getting to the ability to set up a condition to run if something happens. So up until this point in Python, we've just made a bunch of code and then Python runs it top to bottom. We've set up functions and we can set up when to call them and how many times to call them. We call a function, multiple times once we set it up. Like if I had a hello function, I can mine it down this way. I can set up when to call it and call it multiple times. But right now I can't say, only call the hello function if something is going on, or if, something is not going on, call the, goodbye function instead. So that's what we're getting to now. So it's called an if clause, and it's in that list of Python vocab. We'll print it out again. Oops, I need help. So this is my list of Python kind of vocab that we saw in week 1. Let me hide this. This is like all the like kind of built-in language besides like the functions and stuff that we make up. This is all the built-in vocab to do stuff, and we can see pretty simple language. And if is one of the things that's available to us. We'll also be taking a look at else, if and else, if something is true, else if it's false, do that. And we'll also be looking at else, which just means else if, and we'll see exactly what that means logically in a second too. The way to set up a conditional branch is something that looks like this. I'm just going to set up a little bit of logic. So I'm going to make a data object called switch. It's going to be true at the moment. So I'm just setting the switch to like on basically. And then the way that you set up a conditional branch in Python is to say if, and then you do some conditional question, something that's going to evaluate true or maybe false. So we could have something like this. Could have something like this. We just have to ask a question in Python, which we've just found out how to do. So I'm going to say if my switch is on, then I'm going to do following. And you notice I am indenting. So we'll be using indenting again, just like when we set up a function and we use the indentation to define kind of what's inside that function, kind of like define the whole block. We use the same thing with if clauses. So anything that's indented below this if clause kind of like belongs to it. I can kind of keep doing stuff, as many lines as I want. And as soon as I outdent and just print something else instead, and I'm now outside the if block, outside the if block. So this is my if block, since I begin it with the if sentence, and then everything else is indented below it. So that's like inside the if block. So I'm going to push play. Let me remove all this junk so we don't have too much going on. And yeah, we can see, so my switch is on. So when I run Python, Python looks and picks up this in a box, which has a true inside of it. And then we get to this question, if the box switch has is equal to true, then do the following it's saying. So it is true at the moment. So we go, yep, so let's go into this branch of logic and run all the following code. We see that happens on this side. And then once we finish the block of the if logic, then we just go on to the next line as usual. And then we get this line outside. If I switch this off at this point, you can see what Python does is it picks up this data object, sees that it says false inside, then it comes to this sentence. If switch is equal to true, well, switch has false inside of it. So it's basically saying, is false equal to true? So that's a no. So it's going to skip all of these lines of code, and then it just jumps down to this. If this is outside an if block, it can just run as usual. Now we can do that as many times as we want. We can kind of nest that. We've seen that we can like nest things in Python. So we could do something like this. What I'm doing now is I have the same branch of logic, picking up this data object, seeing that it evaluates. So let's go inside the if block. We run all of this, and then we get into a second if question inside the initial one. Is 1 equal to 1? That's just a yeah, true. So then I'm going inside kind of like a double nested line of code, and I'm just printing that out. And then I jump down this way too. And if I switch this off again, you can see I'm skipping this stuff. Since I don't go inside of it, since this equals false, I don't do anything inside this initial if block. But even though this is true just by itself as a single line of code, I don't get to it since I wasn't allowed to go inside of the whole outside if block since I failed the initial condition. So this is true by itself, but I can't get to it since I failed this one and I kind of, didn't go down the path to go from that to this. That's why we skip this and just go straight to the end like this. That's one example. Let's just do a second quick example of setting up an if block so we get the idea of it. Let's jump back to setting up a little Python function. Say welcome to test. I define my function name. I could have inputs in this if I want, but I'm just not going to have anything. I have a function that's just waiting to run. It's not going to accept anything. It's just always going to do the same stuff. So let's say this AI stuff is giving us. We'll outdent and call the function. So let's just see what that does. Yeah, we can see we have a basic function call down this way. When we call the function, we go back up and use the instructions that we had previously written, but we don't use these instructions until we get to the actual function call. It's just the function definition. So without this line, if we comment it out, this doesn't do anything. Python knows how to welcome people, but it hasn't been instructed to yet. So we skip that until then. So now we have a function, now we can add a little bit of if clause to conditionally run this function. I'm going to tweak my code a little bit, and we will use what we picked up last time, which is the input function. Would you like to, okay, we'll accept this thing again. And I'm kind of setting it up tentatively. So I'm asking a question, would you like to come? I will get some response back that I'm going to save in the object called reply. I'm saving the string value and data object reply. And then I still need to fill in the question that I'm going to ask. But once I ask a question, then I can call welcome if I want. And if I don't, I can, I'll just print and so we know that the code is finished. What we can do is we can use the conditional expressions with text too. I might just say like if reply equals yes, they say yes to the question, we will call the welcome function. So let's push play. We can see Python, we'll again just kind of say what Python is doing so we can get used to it. When I push the play button, Python goes top to bottom along the code. It gets to my function definition, and it's just going to memorize how to run that function if it gets called, but it doesn't do anything yet. And it gets down to line 9. We kind of read Python right to left. So I know I'm setting up a data object called reply, but I'm kind of beginning with what am I going to put in the reply box? And I'm running the input function to get something from the console to put into the reply function. So Python is frozen on line 9 at the moment in the console. We'll say yes. And then we can see when we type in yes, reply equals yes. If yes equals yes, that is true. So when yes equals yes, that is true, like this. And then we get inside the if block, and then we can actually run the function at that moment. We can run it again just to test it. If you want to come, let's say no. And what Python does is since no does not equal to yes, it just skips it in the end. So we skip this line and we just get to end. Let's run it one last time and try yes. And we can see this time we typed yes, but it still skipped the function, which it should be doing. And that's again because Python is case sensitive. So I in my code that I'm expecting like an all cap yes, but I just did like a capitalized yes with only the Y being capped. So what we can do is something like this. Let me just type it out. Reply equals yes. And then we'll kind of explain what new thing we have. Now I have like a long question, or I have actually multiple questions at once. Since I'm linking them with this, only one of them needs to evaluate true. And if any of them evaluate to true, then I get to the function. So is reply equal to capitalized yes? No. Is it equal to just capital Y? Yes. No. Is it equal to all little caps? Yes. Yes. This statement in the kind of 3 questions is true. So I go inside the if block at that point. So my thing like this lets me ask multiple questions at once, and only one needs to evaluate to true to execute the if block, we'll say. We do have the opposite available to us. It's not going to make sense in this situation, but I'll just let you know in case you want to begin to think about different code. We can set this up like this with and. Again, it doesn't make sense in this situation, but and would then say that all of these questions would need to be equal to true. And if even one was wrong, but you got most of them, you would fail the whole condition and skip the block. So and means everything needs to be true. If we go back to the way it was with these guys, only one of them needs to be true. So we can kind of like check multiple conditions, and as long as you get one, you can go on inside and run the welcome function. Any questions about if by itself, like how to get inside it, how to like nest it, anything like that? We'll be still sticking with conditional logic, but we'll be adding on the second couple ways to ask questions in a second. Okay, I'm going to move this up and let me, I'm just going to delete this for now since I don't need it. Okay. We see the if block again. This is all in the notes handout from last week. And when we get to week 2, I'll send that out. So we've asked just a simple if question. But now we need to ask, we've seen how we can do something if something is true. How can we do something if something is false? We can see this. So we have to do this. This is the kind of basic option we have available to us. We can ask a question and then do this tentatively based on if we pass this condition. And then we always do the next lines of code anyway. How can we do something like this? Do this if false. Do this tentatively if true. So we want to kind of do the opposite. If something is true, then we want to do that. So we kind of want kind of like a 2-branching setup at this point. So how do we do that? Well, it's exactly as I did it. Let's make this actual Python code now. So ask a question, do something if true. I'm going to set up a little data object again. So I just have switch basically on and off, true and false, up this way. So we can just do it simply. If switch equals true, let's replace this with actual code. And I'm just going to say true. And let's say this is false. And print and like that. And then you might be thinking, you know, how do we swap this out with actual Python code? But it is actually this simple. When we ask an if question, we need kind of a statement following it. But when we get to else, when we get to the else, you just say else colon, and then you indent again like the if block. And then basically, if you fail this condition, you always execute this code if you fail the above. So kind of not asking a question, just asking the question. And if you fail that question, or you fail that series of questions, then you run the else statement all the time. So let's run that just so we can see. So my switch is on. If switch is on, we print out this. Since we did this line of code or this block of code, we don't do this. And then we just get down to the end. But if we come in and say, if switch is now off, we'll run this again. And we can see Python looks at this. Okay, switch is off. Switch is off, so we don't do this line of code. So it always does this line of code instead. We might think this is like testing if it's false, but it's actually always executing. So this switch could be anything, like the sensical question, is it equal true? We think it's either going to be true or it's going to be false. But since this is just else by itself, this could be anything at all. And as long as this fails, we'll get to this anyway. This is kind of the false path of this question, but the kind of the value that this can be anything, if that makes sense. So now we have two branching paths, and again, we can keep asking questions inside of these to ask kind of nested questions. Let me put up a switch 2, and we'll do this little example quick. Type over that. I have two switches, switch and switch 2, both on. And now I'm going to set up a second question. And we'll see about that. We do have a bug in the Python, which I'll do intentionally every now and then so we can see it. We can get used to these. So when we get to this one, it's to point out line 10 is the issue. And what we need to do is, this is the equal sign, and we need to make that a double equal sign to make it say, is that equal to? The single equal sign is like making a data object, so it doesn't make sense in that case. So let's fix that, and then we'll run it again. And then we can see we still have a bug. And again, Python is really good about pointing out the exact place and what type of bug that you have. So let's say now the bug is at line 11. We can see it says indentation bug, expected in indented block, following the if statement on line 10. Yep, I have an if statement. The following line has to be indented to kind of denote this as a block of code. But since I didn't indent, Python didn't know what was going on, so just needed us to clean up. So we'll play that. Now we can see, yeah, we have two on switches. We get inside this big block. Since we pass this test, we print out true. Then we ask a second question. That's also true. So we get inside this. And then we'll continue to skip else and just print to end. When we have a couple if statements kind of all nested like this else is still linked to this if, kind of like at the same indentation level. So this else runs if this one fails, not if this one fails. So if I shut this off like this, you can see I still get inside this block and I still print this. But even though I failed this if statement, this else is not tied to this one. It's tied to this one since it's kind of like indented at the same level. So this is tied to if block on line 8, not this one directly up above it. I kind of had to get used to indentations to kind of see like, okay, this is indented at this level. What is it tied to? Oh, this thing that's indented at the same level up above. And then all of this nested stuff is its own thing inside of this if block. If we wanted to, we could put a second else inside of this, like that. And now this else is tied to this if. So we ask if switch 2 on, it's off at the moment, so we skip this line and we just run the else. And then that's that false that comes out. So we can do as many ifs as we want in a row. We can do like if something, blah, blah, blah. If something, blah, blah, blah. We could do something like that and repeat, ad nauseum. And what's happening in like an example like this is I'm just asking a bunch of questions. And if it's true, I'm going to run the inside, but I don't have any else's set up. But when we want to use the else statement, it always has to be tied to an if block up above it. So I can have a bunch of ifs in a row, but an else can only be exactly below an if up above it. So else has to be tied to a single if that's up above it and kind of like a couplet chain like that. Okay, let's put away all of this and do one last example, like a real example with this so we can see in action, and then add the last thing. We've done if, we've done else, and then we'll see how we can add in elif or else if to finish out the ability to ask basically any logical question, make as many logical branches as we want. I'm going to set up a little like situation. I'm going to have a wallet. I'm going to have $20 in it, and I'm going to have a box called drink. And I will make, this is like the cost of a drink, and this is, how much money someone. Again, when I'm in Python, I'm going to set up all my functions, all my data objects up at the top of the code. And then down this way, once I set up my data, I can actually do stuff with that data in the subsequent lines. Let's ask a question. If wallet is greater than or equal to drink, then we can, you can buy the drink. And else, oops. So set up something like that. I have $20, so I can buy a drink. Let's just test the code. I'm going to change this to be like I only have $5. Let's just test it to see if the logic is all fine. I only have $5. $5 is not greater than or equal to 8.75. So I skip this inside line and I just jump straight to the else. Let's try something like this. Like say we want to ask if we want to like buy a couple drinks, let's like do that in a chain. Drink times 2, print, you can buy 2 drinks. And I'm going to change that back. I have a couple points of code. So I set up $20, drink costs $8.75. I'm beginning with asking the question, do I have enough money to buy 2 drinks? And you can see I'm just doing the math right into my like if conditional expression. I can kind of do that right now if I wanted to. If I wanted to, I could do something like this. I could set up the cost of 2 drinks as its own data object, and then do that down this way. But we can just do the math straight in the conditional expression, so we don't have as many data objects kind of lying around. So can I buy 2 drinks? Yes, I can buy 2. But then I'd go on and ask, can I buy 1 drink? And I get that printed out. So, it's all logically functioning. But like if this was like a video game or something like that, I probably wouldn't want to say you can buy 1 drink. I've already said you could buy 2 drinks. It's kind of obvious at that point. So we kind of want a way of like doing a special logical branch in which we like skip this if this is already true. So what we can do is instead of doing this bit of code, all we have to change is this one little bit like this. And now it's running as we want, and I'll kind of explain what's happening. It's the same thing, running the questions top to bottom. Do I have enough money to buy 2 drinks? I do, so I execute this line of code. And now the next line of code is saying else if wallet is enough to buy 1 drink. And statement is still true. I have enough money to buy 1 drink, 20 to 8.75. But the elif is mutually exclusive. It's kind of like an else block. Since I executed the if block up above, even though the statement itself is true, since it's elif and it's tied to this, I don't execute it since I've already executed an if block up above. So mutually exclusive, and that means else if. And just like else, elif needs to exist in a chain below if statements. So again, I can have like a bunch of if statements in a row. I can have an if and then an else tied up in a bunch. But when I'm going to use elif, it has to look like if, and then elif, and then you can keep going. You can have a second elif, blah, 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 and then ask a second question, blah, 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 and then you can have the else, or you can also skip the else. But basically, what you do when you set up something like this is you ask an initial question, and since you have it with a bunch of elifs, only one of these conditions can evaluate to be true. And as soon as one evaluates to be true, you skip the rest of them, which is why instead of just if, it says else if. Let me change this a little bit, kind of make sense in the situation. You can buy 2 drinks. You can buy 1 drink. And I guess we don't need this one. We'll just do 2 in a chain. Oops. Yeah, so I ask all the questions in a row, but as soon as one evaluates true, everything is mutually exclusive, so only one can execute. And this whole block is kind of tied in a chain. The if, the elif, as many elifs as you want, and then an else. Only one can be true in this situation. If I switch it back to if statements, you can see all the ones that evaluate to true. Let me increase my money a little bit. Now all evaluate and execute independently. They just kind of all exist by themselves. So I'm not really tying these statements in like a logical bunch that is kind of sitting on top of the next one. But when it's back to elifs, now this is one like complete chain of logic, and the elifs mean, again, mutually exclusive. Only one of these will evaluate to true, and the initial one that does is going to execute, and then nothing else will. The end. So I switch it back. I can buy 2 drinks right now, and then I just get to end if I skip everything else. That one is the trickiest one to kind of pick up on, the elif, and like how you tie it into like a chain of ifs and stuff. So that might just take some time to get used to, but if you have any questions about it, you could let me know. We'll do one last example with it now anyway. But yeah, it is a bit of a tricky one. That away. We'll do one last example. So we'll make a function and use if, elif, else to kind of tie everything we've done up until this point into a bunch. I'm going to say fine. What I want to do with this function is I'm going to give it something like 99, 75, something like that, a test grade. And then depending on what it is, it's going to say, you know, like 90 is an A minus, 65 is like an F. So it's going to like kind of translate GPA to like an ABC scale. I'm just kind of like making the skeleton of my function, just kind of leaving some blanks in. I have my function, I defined it, I can put an input, which we probably will in a second. I have the code in the middle that's indented, just like the if block. Functions need to be indented to kind of imply like the function block. This line says what's going to be outputted of the function, what's going to come out on the opposite end. If I want something to come out, I can just leave it blank and then nothing will come out, but it will signal the end of the function. And then obviously step 2 is just going to be to call the function itself. So nothing's going on, it's calling the function, but the function does nothing, so my console is blank. So let's go ahead and set this up using those like if, elif in this. We'll do it pretty simple. We'll say like if grade is above a 90, print A. If grade is above an 80, print B. If grade is above or equal to a 70, print C. And then this is the end of my function. one up. And you can see I neglected to give it a grade. So we want to call the function, we'll give it like an 87 at this point. And since I'm defining the instructions of this function as doing something with an object called grade, we want to accept whatever comes into the function as grade. So I'm calling the function 87 is going to plop into this box. So the box grade is going to get the 87, and then 87 is going to be used to evaluate the question. In this case, next time it'll be 92, and that will be grade in that point. Yeah.
Don't need to give it's the range. Like if the second one is greater or equals to the 18, so the range is contain the first one.
Yeah, so I intentionally messed it up right now. So you can see it's giving out A, B, and C. So the logic of the function isn't set up. So if we you mean like if we change it to like, yeah, so what we want to do is put in Elif instead. And now we can see what we did. Since we made this all mutually exclusive, obviously 92 is above a 70, it's above an 80, it's above a 90. But if we just leave these as if, it'll all get spit out. But we just want to get to like the initial condition. So we stick in 92, it gives us an A. And then since it's mutually exclusive, it totally skips these and just ends the function. If we change this to like an 85, just to test out, it checks this one, but it fails. So it passes this one, prints out a B, and then mutually exclusive at this point. So it just totally skips this, didn't even ask the question, and pops out. Check this one last time with a 75. And yeah, we get the C at this point. This is why the Elif is so useful. So you don't have to have so much coming out. You can kind of ask one question, have a whole bunch of conditions, but only accept like one outcome of that. We'll stick with this 1 second and change it up a little bit to see how we could have the exact same function, but have it look slightly different. One thing that we can see is functions can accept an output. We have an output line of code, but nothing is being outputted at the moment. So you can see calling my function with 75, it's printing out some stuff, it's doing some stuff, but right now it's outputting nothing, and nothing in Python is an actual like piece of data called the none. None is like a special type or value in Python. So it's like, it's not just saying none, it's like value none. So x is equal to none since the function wasn't designed to spit something out at the end of it. That's that. So we can change this. So not only do we print out ABC, but we can like save it in a piece of data when we call the function down this way, and then we can continue to use it, maybe stick it someplace else in the code, stuff like that. We'll change this up a little bit. And this is what we look like now. We only have one output line. We just have a bunch of print statements. But what I'm actually going to do is now totally delete my output line. And we'll run the code right now, actually. And you can see the same stuff happens when we don't have like the output line. And again, this is optional to have at all. Oops. Yeah, we can totally skip this. And what Python does is if it doesn't see an output line and it gets to the end of the indented bit of code, it just automatically ends the function. So I don't even need like the finish stop sign of the function. If I just output outside my function definition, it just automatically knows to end. So that's one tweak that we can do to a function. We can also, if we want to save the code at one point, we could do a couple things. We could swap all of these bits with something like this: x equals A, x equals B, x equals C, and then spit out x like that. I'm not printing it out in the function, accepting it. So now I can save that piece of data and print it out outside the function. So I run all of this, only execute one of them, and then I have my X from, one of these lines. But we can do it one last different way. And again, the way you do it is totally up to you. You can set up a function 1,000 ways in Python. Instead of doing this, I'm going to do something like this. And you'll notice I have a couple of the same kind of like output lines in the code. But that's totally acceptable, and you'll probably see this a whole lot. This is like the stop sign of the function saying kill the function and jump back and just accept what is spitting out. And the reason I can have multiple in my function is because I have mutually exclusive, like logical branches of code. I'm only going to get to one of these logically based on my if, else, and possibly an else statement like this. I'm only getting to one of these, so it's totally fine to have multiple output lines like that. So I added in an else. Let's change this to be like a really bad student. I got a 55. And that goes to my else line, and it's spitting out a D. And I'm saving it. I can print it out. I can do something else with it. Now this is a pretty tidy function that you would probably see people make once they get beyond like basic Python basics. They'll probably set up something like this to make it kind of like professional. Any questions about that? I'll show you the handout. This is the function that we did. One is like an inefficient method. You can just see how much code you have to type out. But it's maybe good to look at to kind of see how you could set it up. But the way that you want to go is like the efficient way or like the less typing way when it comes to code. This is easy to read and see what's going on. This you have to ask two questions at once and kind of find out what's going on. So this way is going to be the easiest way. That's why we wrote a function and then changed it a couple of times until it was as slimmed down and efficient as possible. Again, these both do the exact same thing, but it's just on you, the human, reading the function, on someone who might be coming back to use the function or change it a little bit. You just want to make it as simple as possible so it's easiest to read, edit, blah, blah, blah. Okay. So this we'll just review quickly, though this is in the middle of class 2. We won't stop too long, but just to check back what we've done. We've looked at values. So we have, again, the ints and the floats, the strings, and now we have the Boolean type values, and that's most of the main type of data that you can use: quantitative, quantities, qualitative text, and true false values. We have custom functions. We can just write code in Python line to line, but if we make a function, then we can have a custom piece of code that we can call as many times as we want. So that's handy. We have now conditional questions, like is capitalized John equal to not capitalized John? Is 10 less than the cost of the drink? Blah, blah, blah. And the if, else chain, so we can make now branching code to not only decide when to do something, but if to do something and what specifically to do based on the data at hand. And then finally, we have these all these symbols. One symbol that we didn't talk about, but I'll just give to you quickly, is symbol. This is the is not equal to, and it's the opposite of this one. The second line, I think, is equal to 3 is equal to 3, so that's true. This is saying is 3 not equal to 3, so that's false. But if we change this to be is 5 not equal to 3, then that's going to be true in that case. That's just one of the symbols that you can use. Sometimes it's just handy to kind of ask the opposite question, that you can kind of phrase the code in the way that you want. So we have the assignment symbol, setting up a data object. Double equal sign is saying, is this equal to? We have like plus and minus and multiply. We saw last time how to update values. So the second line is saying the same as update A with its old value plus 3, and you just kind of abbreviate it A plus equals 3. So put 3 into A's own box, which already exists. So that like plus equals, so this could be minus equal, multiply equal, divide equal. It can even be exponent equal like this. It can kind of be anything that you need. And then we obviously have the all symbols, greater than, less than equal to, greater than equal to, like that. Okay. So the next big thing, kind of like the main thing of this series is going to be, now that we have the basics of like lines of code, data objects, and like some like stuff to calculate and ask questions, is the need of what's called loops. So in all coding languages, you'll have things called loops. So this is not just like a Python specific thing. This is like a logical thing that you would do in any programming language. And it's going to be one of the most common things that you use on top of just making a function, making data objects. So let's see. So this is based off the same example that we just had, like welcoming people if they want to come in to dine with us, that little welcome function. Now we've seated people and we've checked that they have enough money. We did those couple of examples. And the next thing is, how can we repeat some code like X amount of times? So if we just look at this without typing it out, we can see we have $100 in the wallet. A drink costs $8.75. We will call the ask function and say, would you like a drink? And then we'll hook them. But then you can see down this way, the main point is, depending on what they say, how many drinks that they want, we kind of have this ugly bit of code that says, if they say they want 1 drink or we have 1 guest, you just call the ask function once. If we have 2, we have to type out ask twice. If we have 3 drinks, 3 guests, we have to call the function ask 3 times. And already we've typed out ask 6 times that way. This obviously isn't the way to go when you have to repeat some code, X amount of times, especially if you don't know how many times you need to repeat it to begin with. So this is, if you have to go up to like 100, that's so many lines of code that you would have to type up. So we'll come back to this actual question in a second. We'll just begin with how to set up a loop and how it will kind of solve the situation. We will jump in, and what we will have is something called a while loop. And while loop is one of 2 types of loop in Python, pretty easy, just 2 types. The second type we'll probably use the most, but the while loop is pretty easy. So we'll just begin with it. It looks exactly like a function and looks exactly like an if block, pretty much, in that the way you set it up is you just say while, and then you have a condition followed by a colon, just like if you had if condition colon. So if you pass this condition, is wallet greater than cost of drink, then on the indented code block, you execute all the code that you want. And then the special thing about a while loop is that when you get to the bottom of the code, the last indented line, instead of going on to the next line of Python code, since it's called a loop, what happens is you get to the bottom line of code, and then you jump back up to the top and run the whole thing again from the top down. And you keep doing that infinitely until something happens, obviously. So on the second run of the code, you run the while loop, you get to the bottom, and then you come back up to the top again. And then you ask the question again while some condition is true. repeat it again. If it's true, keep going. If it's true, keep going. And the way that we'll stop this while loop is to eventually change the condition to be false. And we have to do that inside the while loop itself. We'll kind of flick a switch to say like stop the while loop. And then once we go back up and say while condition, well, that's false now, then we finally escape the while loop and escape it and go on to the next lines of code. It sounds complicated, but we'll set up a really easy example and then hopefully it'll make sense. I'm just going to set up a couple pieces of code so we can kind of see what's happening in the console. So this is going to be a condition. I'll just put it like this actually. So while some condition, run if true. I say if, but I actually mean while true. While meaning keep going on and on, just keep looping. I'm going to indent my code for while block. So anything indented kind of belongs to the while block. And I'm just going to do something like this, and then we'll see what happens when we just run this as is. Actually, we got to put one, we'll do one last thing. So I'm going to say switch equals true. So the switch is going to be kind of on to begin with. I'm always running this while loop while the switch is on. And then eventually, if it ends, we will escape this block of code and just get to the next lines. So when I push play, you can see we made a little boo-boo. Logically, this is going to go until the end of time because at no point do we change this condition inside the while block itself. This is actually still going. It's printed out a couple million times by now. We'll stop that. You can see how many times it kept going on and on because it wasn't exiting the loop. So what we need to do is come in and do something like this. We need to change the code at some point. So if we just do something like this, we can see we run the while loop once, we print out running once, then we switch off false. And then what happens, since this is the last line of while block, this is the last line, we jump back up to the beginning of the while loop and we take a look at this condition. And since now switch is false, we basically say we don't pass this condition, skip all of this, and then just jump down to the rest of the Python code. So we had to switch the flag in the middle. We've only run the while loop once, so let's see how we can run it like X amount of times, even if that's like 1,000 times. We'll have to implement some type of like counting into the while loop. So what we need to do is set up like a true false condition. Let's set up like a count. And let's say if count greater than or equal to 0. Let's change this to count. Let's change this to 10. So I'm beginning with, 10 is my count object. And let's say instead of running, let's just print out count itself. You can take away this. Let's try it. Let's just see what comes out. Again, same thing. We don't have anything changing inside the while loop, so it's just printing out 10 infinitely many times. So let's stop that and implement the changing going on as it loops each time. The initial time count is equal to 10, but we need to do some changing inside the while loop. So let's update count. I'm going to say count equals count minus 1. This is the same thing as this. If you want to type it that way, these lines mean the same thing. This is kind of like the advanced way. This way kind of spells out exactly what's happening. So let's try this way. And now we can see we get what we wanted. So we'll do it from top to bottom so we can kind of get the gist of what's happening. In fact, let me pull up a site that'll kind of show us what's happening. And this is a good site that you can use as you begin to do Python coding, and you'll see why it's useful in a second. Okay. This site is running my Python code. I pasted it in. And the nice thing about this website is it's going to run my Python code line by line and exactly tell me what's happening behind the scenes. When you begin, Python begins at line 1. My next button is going to be like each line of code as it gets executed inside the Python machine. So it prints out begin and then it jumps down to line 2. This goes top to bottom. It is going to establish the data object count, and that's set equal to 10. This is kind of like holding that data object in its Python hand. And it gets to the beginning of the loop. Since this n is above or equal to 0, it passes the while loop and jumps inside of it to execute these lines. Obviously, it's skipping the comment. That's why it skips this line. Comments don't mean anything. Click next. Prints out my count. So this is my console. It says 10. Next. Then it runs this line, count equals count minus 1. And we can see kind of in Python's machine hands, now count is equal to 9. Then once it finishes the last line of the while block, it jumps back up to the top of just the while block, not the whole Python file, just this block. It's going to ask the same question again. Is count, which is now equal to 9, above or equal to 0? Well, yes. I'll keep clicking a couple of times and you can see it's kind of running the code, looping the same thing again and again. But the key thing about a loop is that I'm updating the thing that my condition is dependent upon, so that eventually, based on when I want it to, it's going to get to the off condition, which is right now, count is equal to 0. And then I'm asking while count is above or equal to 0, run the code. Since it's above or equal, it's going to run it one last time. Actually, my last data value of count is -1, but now that it's -1, it's still looking at the question one last time. -1 is not above or equal to 0, so now it totally skips this and just goes on to the rest of the code. This is a really good site. You can go line by line. You can see the console, and in this little spot, it's going to show all the data objects you have, what values they have, and how they get updated as you run through the code. This is Python tutorial visualizing code. That's a really good site to go to, especially when you do things like loops in which a lot is happening with a little bit of code. It's easy to kind of misjuggle the data objects that you have and things go awry. So good way to visualize it. Okay, we'll do one last example with a while loop. That was a pretty easy one, just counting down. We could have easily just changed this to be a plus and counted up instead. I could have counted up to 10 just by changing it to plus and less than or equal to. But let's delete all of this and do one last example. In this example, I want to sum everything between 0 and something that I pick, 100, 1,000, 27. I'm going to be like 0 plus 1 plus 2 plus 3 all the way to the thing that I've selected. So we'll make a function that does that. I'm just setting up my kind of skeleton of the function. I'm going to call it down this way. And my n is going to be what I'm going to be counting up to, summing up to. So I'm going to expect, I'm going to give it something. Let's give it something simple, just so we can kind of do the mental math and check it. I want to add everything up between 0 and 3. So 0 plus 1 plus 2 plus 3, we can do that mentally so we can check it. Let's call the input that we will be expecting. We can just call that n. You can call it x. You can call it like max if you want, anything that you want. We'll call it n. And inside, now we need to probably use a while loop to be able to count up from 0 to n. I'm going to set up I have a function called total, but I want to make a data object called total. That's going to be the sum that I have in the end. So total equals 0. I'm going to make like a beginning point, which is 1. You can make it 0, but 0 won't add anything to the sum. So let's actually change this to be 1. Beginning at 1, n is going to be my end point, but I already have it, so I don't really need to type it again. But yeah, so we have a total, a beginning point, and a stop point to count up to. That's my data object in my function. And now we'll come in and do the actual bit of looping to do that. You can see Python is, the AI has gotten quite good at giving us exactly what we want, basically. But we'll kind of do it slowly. We'll set up a while condition. And the condition will probably be while beginning and so this is going to be my beginning, but if you want to call it like step or something, so I'm going to keep changing that to be 1 in the beginning and then 2 and then 3 as we count up. If you want to call that something else to make it make sense, but while that is less than or equal to n, we will do the following. I'm indented in my while loop. I'm going to say total plus equals, and I'm going to call this here, we'll call this step just so it makes sense. I'm stepping up 1, next time this will be 2, 3, and we'll just keep counting up until we get to n. I'm going to call that, step. Add each step to the growing total. And then what we'll do, we'll come down to the bottom, just print out total. We could output it, but we can just print it out too. So let's see, let's just press run if we get too hasty. And we can see nothing is happening, but it's still running. So let's pause it and maybe put like a print statement inside. Let's print out steps so we can see what that's evaluating to each time. You can see we have a couple steps left to do. We've added to the total, but this is just running to infinity. So what we need to do is say step equals 1. So increase, yes, thanks AI, increase the step by 1 each time inside the loop. Let's try that now. And then, we can see that we, looks like it's coming out now. So we'll run down the function the whole way now. So we begin the function, set up a total, which is blank to begin with. We set up a step. It'll be 1, 2, 3, all the way up to n, which in this case is just 3. We'll ask the question, is step less than or equal to the stop point? So at this point, 1 is less than 3. So we execute the inside code. We add 1 to the total, step equals 1, add it to the total, and then we increment step. So now step is 2. And so we can see when we print out step is equal to 2. Bottom of the while loop, so let's jump back up. Step is 2, step is less than or equal to 3. We'll run the code again, add 2 to step, add 2 to total, and then add 1 to step. Step was 2, now it's going to be 3, so that's what gets printed out. And then we'll go back up to the top. Step is equal to 3. 3 is equal to 3, so we go back inside one last time, add 3 to the total. We increment step one last time, which we can see this way, but we haven't added it yet. That's kind of waiting on the next loop of the code, but we print it out. That's how it's coming out. And then we'll run it again. So this is not true at this point at the last attempt to run the loop. But since this is not true, we skip all of this one last time, and then we get the final output in the end. And so we get down to the print total line, which only runs once it's finished with all of the continuous looping. This one is a bit tricky, maybe actually less easy than the last one, just because with the while loop, you have to manually handle all the counting by yourself. We have to set up a total and keep track of it. We have to set up a step. keep track of it. We have to keep track of the stop point. A lot of like manual checking going on. But that's just how we use a while loop, and it gives us a lot of options to kind of do anything that we want with it. But the next type of loop, it's going to be less bulky than this actually. But this seems kind of annoying. The next one is actually less annoying than this, and the next one we use the most actually. But this one is a good one to begin with, because you kind of have to know everything that's going on behind the scenes ahead of getting to the kind of simple addition of a loop. Let me jump back to my handout. That's the code again, simplified down. Again, this will be a good one to stick into this. You can just kind of visualize it step by step. Okay. This one we won't type out, we'll just look at it because I have it on the page since it's so much code. So just kind of, we know the situation that we've been kind of building on, but we'll just kind of read this top to bottom and kind of see, and hopefully Python is becoming kind of easy to read, just like, the English language. Top to bottom, I'm establishing 6 guests. I have, $50 in someone's wallet, maybe everybody's wallet combined. And I have something called a drink that's $8.75. Probably, again, the cost of the drink. You can see when you name things, it's good to name them the logical thing it is. So anybody can come to this code and read it and make sense of it. And you can also come along and add comments to kind of additionally explain things in English. So it'll be helpful to anyone who's reading the code. Okay, and then let's get to bulk of this. So we have a while loop being set up. While guess is above 0. Yeah, let's just jump in since guess is equal to 6. So let's see what's happening inside the while loop. So we have an input statement. And let me show you what this bit of code is actually. I haven't demonstrated that yet. Print name. This bit of code is called an F string. You can use it in print statements. It just looks like this. Looks like a string inside of a print statement. It has a little F, or it can also be a capital F next to it. And the useful thing about it is you can stick data objects inside the string. And then when you print it out, instead of saying, box called name, it'll actually print out the actual content, the value of name instead. We can have this little bit of line, and then we can change this anytime, any way that we want, and this will always be outputted as the dynamic value of name instead of doing something like this, in which we would have to update this each time and update it in multiple places. We can use an F string to do that just on the fly. So that's what this is. So we can imagine this is like the waitress saying, seat 1, some guest at this seat, would you like a drink? And then while she's, noting who wants what, she's just going to -1 from the count of guests. She's asking guest 1, we have 6 guests. Since I'm in the middle of asking guest 1, I only have 5 guests left. So the Python waitress is just kind of keeping track of how many people to keep asking. And we can see that's going to come in handy as we decrease guests 1 by 1 until we have none left. That's going to help us end the while loop up top, because eventually we'll have no guests left to ask a question, and that's how we will escape the while loop in the end. I'm asking, seat 1 or seat 6, would you like a drink? She's ticking off, I've asked 1 guest. If the reply that we get from input, which is saved as this data object, is equal to, again, we do the same thing, yes, yes, capital yes, blah, blah, blah. We will do something. But now we have quite a lengthy question. We can see we have this bit of stuff asking multiple questions, but I only have to pass one of them. And I have that in parentheses to say, like, this is one block. I'm asking a couple questions, but only one of them needs to pass to be equal to true. And then we have this and statement, which I showed us a little bit ago. And that's saying the second question has to be true, as well as one of these needs to be true. I'm kind of asking two things. Thing one is one of these needs to be true. And the second thing, joined by and, is that I need to have enough money to actually buy the drink. So I'm asking, would you like a drink? And do you have enough money to buy the drink? If I pass both of those conditions in my if block, I'm going to take my wallet and minus the cost of a drink out of it. I'm decreasing the wallet and keeping track of how much money is left. I'm using a print statement to say, this is the drink. You have, X money left, because I'm printing out the contents with the value of wallet. So that's what happens if they say yes. If they else if say no, capital no, I will print out, this instead. And if I get to the else statement, it's probably going to be, we can kind of logic out. They didn't say yes, they didn't say no, but they were probably tripping them up to get to the else statement is they don't have enough money at this point. Because if they don't say no, but they say yes, but they don't have enough money, they won't do this anyway. So that's when they get to the else. And that handles the, you don't have enough money in the wallet. So we ask guest in seat 6 at the bottom to that bit of code. Then we pop out back to the top. Now I'm on guest 5 with slightly less money in the wallet, and we'll do the same thing top to bottom. Do you want a drink? Do you still have enough money? You guys, blah, blah, blah. And then we'll just keep looping. And then eventually we will have asked all the guests, and we will escape the while loop and, finish the code. One new thing that we see is this break line. And this basically is kind of like the output line in a function. When you get to a break line in a while loop, it basically crashes the whole while loop, like in a good way. And it totally escapes doing the rest of the loops and just moves on to the rest of the code. We can imagine if wallet was instead like $10 and guest 1 got a drink and they only had 125 left. Guest 2 out of 6 also wanted a drink, but they don't have enough money yet. Then we get to the else statement. We say, you guys, all 6 of you don't have any money left. So we will break the while loop and we will not ask the rest of you if you want a drink, since we already know that you guys don't have enough money yet. So money left. So the break line is just cutting the whole function with the whole while loop right away and just kind of skipping asking this condition again. So that'll be useful as demonstrated in this case if you want to cut it and kind of use like a second condition to escape it. Okay. Okay, so the rest of the stuff in handout 1 is just going to be, we won't do it today. I'm going to leave them as like practice problems. Again, you obviously don't have to do this. This isn't school. But these couple of practice problems, I included, the question, how to set it up, some hints, some ideas. And then I've included all the, a solution to each of them. I have 1, 2, 3 questions in kind of increasing complexity. And if you can do all these, that's pretty good. You might not be able to get them all right away, but that's a good place to practice. You can see they all have quite a few lines of code. This one I actually have 2 solutions, it looks like. So these will take a while. These will be like big questions that have a lot of lines of code, a couple branches of logic. So it's a good project to kind of wrap up all that we've done up until. So I will leave those. You can do it at any point. If you have questions at the beginning of next class, we can look at them if the solution alone don't help you. So we'll leave those. With all that I've taught you, you should be able to do those. Might just take some time, but now we'll jump on to the week 2 stuff. So this is a couple of the things from week 1. So I'm going to jump down. We just did the while loop. This is the solutions. And yes, we want to get to what's called lists now. A list is a new type of data. Right now, we actually have all the basic types of data in Python. We have all of them. We have, quantities, whole amounts, decimals, floats is the decimals. We have a string, which is any piece of like alphabetical text or anything. And we also have Boolean true false values, which let us crucially handle like questions and conditional logic. So that's all the basic types of data in Python and in coding. And the next type of data that we want to look at is what's called a collection or a sequence of data. And all it is it's some group of a bunch of these pieces of data. So we can think of it as like a bucket of multiple pieces of all of these. Oops. So a list is one of them. We also have dictionaries, tuples, and sets. List is the most useful one. This is the most this is also useful in its own way, and tuple and set slightly less useful, but they each have unique things about them. In this class, with the time we have left, we'll probably just get to the list and maybe dictionaries, and we'll see once we do both of them that they kind of handle most things. These two will be the main two types of like data buckets. Okay, so let me hop into Python. And we'll take a look at how to make lists, how to set them up, how to like access them. Let me jump to my notes. Okay. So just like any piece of data in Python, we just begin with the name of the object or the name of the box on the left-hand side, equal sign, and then on the right-hand side, it could be anything. It could be an int, it could be a float, it could be a string piece of text, could be a Boolean value, true, false. And it's the same with collections. It's still just a type of data. So this is how we make an empty list. Just kind of like an empty list. Nothing is in it, but we just have a bucket that can have stuff in it. I'm just going to print this out. You can see when you print it out, it's just the same thing. This just means the boxy bracket makes a list. I'm printing out my list. We can also use some of the stuff we have from last time. So we can use like the type function nested inside the print function and say, what is the type, the official like Python type of this data object that we just made? And it's going to show us, yeah, that's class list, which is obvious. But we can use type all the time to check what a piece of data is if we don't know what it is to begin with, or maybe we did a bunch of changes to it and we just want to check that it's still what we think it is. So this is a blank, I guess I should say, empty list. Now we'll go ahead and instead make a list, like initialize it with a bunch of data in it to begin with. So what can we put inside of a list? Well, we can put any of the basic data types. So we can put in floats, we can put in int, we can put in string like this. You can see that I'm putting in multiple types of data into the same list, so that's totally fine. We can have quantities next to strings, next to some like true and false Boolean values, like that. That's all totally fine. Usually you'll probably have like one type of data, like we might make a function that like calculates the average of a bunch of test grades in one class. So that'll be like just a bunch of floats in a list. But it's totally possible to have as many basic data objects in one list as you want. And any all types at once. The list is pretty open-ended. It's just a bucket. You can put in any of the basic data types you want in it. If we print it out, we can see that it comes out like this. Yeah, so we just use commas to separate each distinct value. So we just use commas. Again, spacing doesn't affect anything except like visual conventions. We can skip the spacing, still comes out the same. So it's kind of less legible, so we like the spacing. And one thing that you'll kind of notice is sometimes a list will end with a comma but not be followed by anything. And that's totally fine too, that this is the same as just ending without a comma. It's just kind of what you like. Actually, I think this might be the conventional way, just ending with a comma. But I think I've seen it both ways enough that you can kind of choose which way you want to do it. But yeah, commas separate each value and possibly separate the last value from nothing, just the end of the list. That's totally fine. So we have that. One last thing that we can do with lists, and we call this list 3, is we can just actually let me say name equals John. I made a data object called name. Up until this point, I've just been putting in actual values into a list, but we can just as easily the exact same way, just put in the data variables themselves. And then when I access this list, instead of saying name and the list, it'll output John, since that's the value of John at this point. So we can put in the values as well as the kind of box label as well. That's totally fine. And then the last thing that we can put inside of a list is lists themselves. So we can have like a list of a lists. We can do something like this. The list, my list, you. And then I guess I should put this out. You can see with this last list, what it is I have my brackets indicating the outside-most list. And then inside of that list, we have a blank list. And then we have a second list, which has all of its individual content. So we can kind of think of it as like a shopping list. You might have a big list when you go out to run a bunch of stuff on the weekend. And then inside that big list, you have like a food shopping list and like a Home Depot list. And then maybe in the Home Depot list, you have like the Christmas aisle list and the like cleaning supply list. You can do all types of nesting. You can have a list of multiple lists, and then you can nest them as many times as you want. So we could do something like this if we want. It looks really funny, kind of confusing right now, but it's totally acceptable to put as many lists inside of lists as you want. But obviously, we won't do that now. We'll just stick with the basics right now. So that's how we initialize a list, just make a collection of stuff. What we'll want to do next is once we just like make a list, including possibly just a blank list at the beginning, is how can we add stuff to that list, like as we do calculations in a function, and then maybe how can we take stuff out of a list if we want to, take things off a list and empty it out until we finish doing all the stuff. So to add a single value to a list is going to be something like this. I'm going to begin with a blank list. And then to add a value post creation of the list, it's going to look like this. Try not to use typos. It's called a dot method. You use dot append parentheses tied directly onto the end of the list itself. And this is basically a function that you put something in the parentheses, not a function name, but you just use like the dot method, which is basically putting a dot between the function and the object you want it to act upon, like this, instead of like calling it like the usual functions that we've been seeing. You can see down this way, I make a blank list. I'm going to append just the value 1 to the list, print it out. So we see we just have a list of 1. I'm going to append 2. Append always adds to the ends of the list. So we can see when we add in 2, it hops onto the end. Then we print it out, we see it again. List append 3, print. So we can see we can just keep going like that. So that's how we add stuff into a list. And then the way we can remove stuff from a list. Remove item from a list. And when I say remove item, I mean last item in this specific situation is going to be list. Something like that. So we added 1, 2, 3 to the list, 1, 2, 3. And then I'm going to do list dot pop. And that's going to, I'm not going to give it anything because I'm not putting anything into the list. It's just kind of like a blank function call called pop. And what it actually does is it kind of spits something out of the list. So when I pop the list, you can see it goes from this to this. So it removes last item from the list. One last thing we can do with pop, I would say pop equals something like this. You can see now when we pop the list, we kind of set it equal to something. A pop is kind of like a function, the dot method function dot pop. It's kind of like a function, so it still can output something. So what it's outputting is the thing that it kicks off the back end of the list. In this line, it's kicking out 2 from the list. So when we print the list next time, the list just has 1, but the props object that I just made, I can kind of have 2 by itself. So 2 is not in the list now. I've kind of ejected it from the list and I'm kind of holding it in this object called popped that can do anything that I want with. You notice up above, we did not know popped. So if you pop a list and don't like accept the ejected object, it just kind of like vanishes. It just kind of goes away. Just like if you end a function without outputting something, it just kind of ends it without, doing anything at the end of it. So we can do stuff like that. We'll just stick with these basics at the moment, making a list, filling it with anything that you want, adding on to the end of a list and removing onto the end of the list. Obviously, you'll want to be able to do things like access a specific thing in the middle of a list. You might want to add a value at the beginning of a list, remove the 5th value in the list instead of the last value. But just since it's a basics class, we'll just say, we'll just add stuff onto a list and remove stuff from a list, and that'll get us through the basics. Okay. I'm going to delete my notes. You can keep y'all's if you want. So my teaching screen is clean. And now we will jump to the second type of loop in the last couple minutes of today's class. And let me jump to that, which is going to use the list, obviously. We jump to 2. And yeah, now we have the second type of loop. And just a bit of review, the while loop runs as many times as you set it to, based on some condition that it keeps checking until it evaluates the false, and then it escapes the loop. This type of loop always runs a set amount of times that it knows from the beginning. So it's not checking a condition. You basically know at the beginning of this type of loop, it's going to run X amount of times. So let's set it up in this so we can see it in action. I'm going to make a list now that we know how. Right now I'm just making a blank list. I'm calling it grade. So let's just give it, student grade. You don't have to add, we won't add that many so it's not too busy. I have a list of grades, just like that. Now we'll set up the new type of loop. And we're kind of set it up step by step. This is kind of what it looks like. Again, like all the things we're doing, like while loops and functions, we see an indent. We see like a colon on the end of like the beginning of the block of code, denoting like that's the beginning, and the indented stuff is the block that executes how many times it does. In this addition of the loop, we can use this type of loop a couple different ways. In this edition of it, the way that we set how many times we want it to run is we give it something like a data collection, which has multiple data objects inside of it. So we give it something like a list, aka grades. And what it's going to do is it's going to take grades and give you one object at a time each time you run the loop. And then once it gives you the last object, the list is empty. So it's just going to finish the loop at that point. We have grades we made up above. This little blank line that I left in, we can call this anything. This is the one item or one element at a time it's going to give us. We can call it anything we want. We could call it X. Usually it makes sense to call it what it is in that given bit of code. I'm going to make up the name grade on the spot, and then I can print this out down this way. And then I'll put one last bit of code just so we can see code finished. Just push play. And then, yeah, we can see this type of loop is running exactly as we want. We've established a bunch of elements inside of a list. And then when we get to the loop, we say, give me one grade at a time in the grades list. And then we run each bit of code inside of it. And each time we run it, grade is always going to be the active element that it's looking at a given time. So on loop 1 is 100. Then when it goes back up to the top and runs the whole thing again, top to bottom, next time it's 90, next time it's 98.5, 78, 86. And then once it gets to 86 and does the last loop, then it just ejects from the loop automatically. It can't run to infinity by accident, this type. And then we just exit, do any last bits of code that might be hanging out in the file. And then that's all that we need. So this one's really handy. We can have, now that we have a list, we can juggle a whole bunch of pieces of data at once. Instead of just one grade, we can have a list of 1,000 grades if we want. And if we have 1,000 pieces of data in this, we just need 2 lines of code to cycle 1,000 times if we wanted. So loops really handy to do something a bunch of times, to do something to every single element in a collection of data. Basically, anytime you do a whole bunch of stuff, a loop will come in handy. One last thing, just a new function we'll take a look at now that we have a list. It's going to be something called the length function. And this is just going to tell you how many elements you have inside a list. So it's the length function, but it's just len like this. And that basically just gives you, again, the count of how many elements inside of a list. So length of grades is you have 5 things inside of it. So length is 5, does that line, and then it does the rest down this way. Length will come in handy a whole bunch of times. That's a useful thing to have to automatically count something instead of, kind of manually doing it to keep the code dynamic. Okay, that's one way to use a loop. You just have like something with a list with like X amount of things inside of it. But what if we just want to like loop? What if we just want to like run a loop X amount of times, but we don't have like X things? Like we could have 100 grades, and then we would stick that into a loop, and it would run 100 times. But what if we just wanted to run something 100 times, but we don't have 100 things? So let's take a look. And something like that. So we just wanted to run this X times without using a list to cycle each element of a list and kind of counting that way. We just want to count, we don't have an actual thing to be counting. So this is going to be an additional new thing that we need, and we'll kind of do it step by step because we can do a lot with this one thing. I'm going to call my each element of the loop X, and then what am I looping to get, instead of like X, so let's call this like 10 times. How do we just run a loop 10 times and count? Oops. I'll set it up and we just push play so we can see it came out. And yeah, so this is the range function. And there's a whole bunch of stuff you can do with it. But yeah, we can just see from the beginning, pretty easy to set up and run something. We want to do it 10 times. You can see 10 loops happened, but we just see one finicky thing, which is you would expect maybe like 1 to 10, but we actually have 0 to 9 on this time. It's still giving us 10 loops, but it's just not counting the exact way that we want. The reason that is in Python and all programming languages, usually you begin counting at 0. And there's a whole bunch of reasons why you would do that, which we'll see eventually. But yeah, we don't begin counting at 1, we begin counting at 0. So if we want to count to 10, but we begin at 0, we just end at 9. So we still have 10 items, but we do 0 to 9 instead of 1 to 10. The beginning at 0 is called, that is called 0 indexing. We count from 0 in Python. That you just have to get used to. Again, you'll come across a whole bunch of reasons why that'll begin to make sense to you, why you begin counting that way. But that's just ubiquitous, so you'll get used to it pretty quickly. So let's go back to the range loop. Range means like something to something, so it makes sense to call that. We want to get from 0 to 10, rather 0 to 9. This is what the full range function is going to look like. Let me set it up. So we talked in Python how you can have like optional things, like when we have a function, we can set up function name, x to y equals 2. We took a look at this last time. Second one is like optional. So when you call this function, you only have to supply it with x. If you don't supply a y, it's just assuming it'll just give you a y that equals 2. But if you don't assume the y, you can get it like a 5 instead. This is kind of the same thing with the range function. In this function, the stop point is the only thing that you need to supply something. If I just have one thing in my range function, that is my stop. That's basically saying stop at 10 and begin with the default of 0 and counting up by 1. So what this is saying is range 10, begin at 0, technically, end at 10 and count up by +1. And the unique thing about stop, the last little bit of the puzzle, is stop is equal like a stop sign. My stop is 10, but my analogy is that it's like a stop sign. You want to stop ahead of the stop sign, not like exactly at it or beyond it. So when I say stop at 10, I'm actually saying get to 9 and then actually get to 10. 10 is the next thing, but I'm actually not going to touch it. When my stop point is 10, I'm actually going from 0 to 9 actually, and just counting up by 1 each time. So beginning at 0, counting up by 1 each time, each loop, just adding on 1, and then stopping at 9 technically. So this is kind of it in full. We can skip the plus. I was just in this notation. So my range is 10. That's the same as this. Begin at 0. That's kind of inclusive. Stop at 10. That's exclusive. So don't hit 10. Just get to 9 and then leave 10 just out of reach. And then count up by 1 each time. So we'll try that again. So this time, say we want to count from 1 to 10 instead of 0 to 9. Let's do that down this way. Of a different one. And so I want to begin, I want to change my default to 0. I want to say begin actually at 1. We want to say we want to get to 10 and we want to count up by 1 still. You can see I almost did it. I began at 1, but again, my stop sign is 10, so I'm stopping at 9 actually. If I want to get to 10, I'm going to say my stop sign is 11. And then you can see on the second loop with the Y's, I'm going from 1 to 10 down this way. So again, my 11 equals stop sign, last actual value is 10. That's a bit confusing, but again, this type of thing of like having like an exclusive value of like stopping just ahead of it is something that you'll see a lot in Python, that and the zero indexing we just talked about. You'll see this a bajillion times and use it almost anytime you do any bit of coding. So even though it might be confusing right now, it'll just become common to you, and you just do it by instinct eventually. Let's do the last couple things because we have so many options with this. So we set up the basic one, tweaked it a little bit. Let's do an example. Let's count down from 10 to 1 using the range function. So we'll try that. So we'll say v in range, print out v, and we just had to set it up the same way. So we have the beginning point, stop, and step. We want to begin at 10. We want to stop at, actually we'll say we want to get to 0. So if we say 0, it's actually going to stop at 1. So if we want to say 0, we want to say the stop sign is -1, which is the next thing just out of reach. Let's try that. Just say begin at 10, go to -1. And you can see it's not quite doing it. But if we do something like this, we want to change the step. So step is how much you add on between each loop of the cycle. So in my last one, now I'm going from 10 all the way down to 0, begin at 10, end at 0. So my stop sign is -1. And my step, how much I change by each time, is how much I change the z by each time is -1 each time we loop. So 10, 9, 8, 7, all the way down to 0. -1 is next. We stop ahead of touching it. That's how we can count down with the range function. We can do different cool things with range. Let's go A, range, A. We can do something like 0 to 10. So I'm going to 11, but this time count by 2s. So my step is 2. And then you can see in this one, 0, 2, and I'm counting up by even. We can do all types of cool stuff with the range function, since we have so many input options to that function. We have 3 inputs, 2 of them optional, but if we use all of them, we can do a whole bunch of cool stuff when it comes to counting. The range function packed on to this type of loop is going to be the best thing to kind of do anything X amount of times. So now that we know how to do all this, I can easily count from 0 to 10,000 if I want. With just 2 lines of code, you can see I can do all of this. I can do a whole bunch of iterations each time in that bit, and I can get all the way to 10,000 pretty easily. Python calculated that in like half a second less. Now that we have loops, now that we have the range function, now that we have all these little things, now we can begin to be able to do any type of massive calculation, like the bulk size of something is not an obstacle to us. We can do things any amount of times. We have a list which can handle lots of data, and we'll use that again in a second. So now we have a lot of the basics of coding that we can do kind of anything with. So let's tie all of these into one and do an averaging function with like a class to tie all this into one lesson. We just have a couple minutes left, so we'll do the beginning step of this process, and then the like extra step we'll leave to do next time. Find the class average. So I'm setting up a function. Again, I'm just practicing all of this again and again. We'll see this again and again, but that's a good thing that we just see the same thing and can repeat it and commit it to memory. Let's say we want to calculate Tom's class average. He's taken, 5 tests. Give him that's too low. Give him a couple of tests. So he has, 5 tests. I'm going to call the average function in the Tom list. And let's say we haven't coded it yet, but let's accept something from the average function. And that'll be something like this. Average is X. Right now I don't have the function, but we can see it's all running as expected. But my output is nothing, so that's why Tom's average is none. Let's quickly put some code into this box, and then we can see it come out. So we'll have to set up a loop. We want to find the average, so we'll set up a blank total. So we want to add everything up by, and then divide by how many tests that he's taken. Make a total. I'm going to set up a loop. We have grades. We stuck in Tom. We just name it grades in the function. We'll look at one grade at a time out of all the 5 that we have. I want to add each grade individually to the growing total. That's going to be my loop. That's 2 lines. We can space this out a little bit so it's less difficult to see. Once I add everything up into a total, I'm going to make a new object called average. We can see again, Python is spoiling it. We just want to take the total and divide it by the amount of tests that we have. Obviously, we want to like put in 5 into this because then we want to be able to use this function next time. This is Susie, and she actually took, 6 tests. We don't want to code in 5. Instead, we want to do length of grades so we can dynamically find how many items in that list, depending on that specific situation. We don't want to code like problems. We want to make a set of instructions that can apply to any bit of data that we stick into it. Let's just take a quick look. We begin with a blank total, stick in each grade to the total as we do the loop of the list. So we run this 5 times to add grade to total. Last step, once we escape the loop indent, is going to be take total, divided by length of grades, which is 5. Let me take this back. Divide that, make it something called average. Once we have this data object, we can output it. And that output will be accepting as something called X. We could have named it average 2 if we wanted to, same thing. And then we can see, it comes out exactly as we want. He has an 88.6. If we change this to be Susie, and she took a bunch of like extra credit tests, we can see we can change the amount of tests, but the code is still running the same. Let me get that. And we can also stick in one last thing that we talked about last time, which is the round function. So I can stick that in any place. I'll just do it like this. And then we can get like 2 decimal points on the average using the round function round. Okay. Yes, that one's pretty simple. Apologies if I went too fast on that one. But next time, next time in the meanwhile, you can go back to handout 1 and take a stab at some of the assignment problems that I gave you. And if you want, you can also take a look at handout 2, which I will email out in a couple minutes. And what happened to... we'll leave it at that. I'll finish out the slide next time since it jumps up in complexity a little bit. So practice, so you can just go back and do these couple big problems, which could take you a couple minutes minimum each, which will be good practice. Let me copy